All right, welcome. In this explainer, we're diving into a real cosmic heavyweight mystery. And it all kicks off with a pretty simple question. But trust me, it leads us to one of the biggest puzzles in all of science.
So the question is this: how much does our cosmic neighborhood weigh? Sounds straightforward, right? But you can't just, put a galaxy on a scale. So when astronomers got really clever and measured how things are moving, they found something profoundly weird. Our galactic group is far, far heavier than it has any right to be. And this really gets to the heart of the mystery. On one side, you have the visible mass, everything we can actually see. The stars, the gas, the dust. But on the other side, you have the mass that you calculate from motion. And here's the thing, gravity doesn't lie. And it's telling us there's a shocking amount of something else out there, something totally invisible. Okay, so to solve this thing, we first need to check out the scene of the crime. And that is our very own cosmic backyard, the local group. The local group is basically our galactic family. It's a collection of over 50 galaxies all bound together by gravity. But really, it's a two-player game. It's dominated by two absolute heavyweights, our own Milky Way and our slightly bigger neighbor, the Andromeda galaxy, which is also called M31. Now, for decades, the story of how these two massive galaxies were moving was, it was explained by a really simple, elegant theory. It looked like a pretty straightforward cosmic dance. This idea was called the classic model, and it was a beautifully simple concept. The Milky Way and Andromeda were born close together. They flew apart during the Big Bang's initial expansion, but their immense gravity was just too strong. So they slowed down, turned around, and now they're falling directly towards each other for a head-on collision. Think about it like this. You throw a baseball straight up in the air, right? It flies away from you, it slows down, it stops for a split second, and then it falls right back into your hand. In this classic model, the Milky Way and Andromeda are just like that ball, moving on a nearly straight path. Simple, elegant, and for a very long time, it seemed totally correct. But, and this is where it gets really interesting, new observations have completely shredded that simple picture. The universe, as it turns out, has a few curveballs to throw our way. Yeah, just when we thought we had it all figured out, new measurements came in and showed that the simple head-on collision model, it's just wrong. So here are the plot twists. First, new measurements revealed Andromeda isn't just barreling straight towards us. Nope, it's got this huge sideways motion. So it's not a fastball, it's a curveball. Second, you've got other galaxies, like the Large Magellanic Cloud, that are also tugging on everything, which messes up the math. And finally, the expansion of the universe itself is actively trying to push everything apart. Each of these new facts just makes the puzzle that much harder. So, what does all this mean? Well, think about it. If something has a lot of sideways motion, it's much harder to keep it from just flying away. For Andromeda to still be on a collision course with us, despite that sideways spin and the push of cosmic expansion, the gravitational pull between our galaxies must be absolutely immense, way stronger than we thought. And stronger gravity means only one thing: more mass. A lot more mass. So how much more are we talking? The new calculations point to a total mass for the local group of around 5, get this, trillion times the mass of our sun. That is just a staggering, mind-boggling number. And it's so much more than all the visible stars and gas in the Milky Way and Andromeda combined. So here's the crucial question. If this colossal amount of extra mass isn't coming from stars or gas or dust, what is it? And where on Earth is it hiding? This isn't just some rounding error. This huge gap between the mass we can see and the mass we know has to be there. It's the central clue in one of the biggest detective stories in all of science, and it points directly to a suspect that's been lurking in the shadows for decades. And that suspect is dark matter. That's the name we give to this mysterious, invisible stuff that makes up the vast majority of the universe's mass. It doesn't shine, it doesn't reflect light, it doesn't interact in any way we can directly see. But, and this is the key, it has gravity. And that's the gravity that's holding our local group together so tightly. This brings us right back to the science. The researchers themselves say that with better measurements of how galaxies are moving, what they call precision future kinematics, we can finally start to map out this invisible substance.
The goal is literally to use the light we can see to shed light on dark matter, right here in our own neighborhood.
So where does this cosmic detective story go from here? Well, the case is far from closed. In fact, it's just getting more and more exciting.
You see, science is a journey, right? We started in the past with a simple, elegant model. Today, in the present, new data has forced us to accept a much more complex and massive reality. And for the future, the name of the game is precision. We need to refine these measurements even further to truly pin down the properties of our cosmic home.
And really, the stakes couldn't be higher. Solving this puzzle won't just tell us how much our galaxy group weighs. It could reveal the fundamental nature of dark matter itself. It could explain where our galaxy's spin came from. It might even let us test the basic rules of the universe with incredible precision, all from looking at our own cosmic backyard.
So the next time you look up at the night sky, just remember, those beautiful little pinpricks of light, they're only the visible part of the story. The real drama, the true cosmic weight, and the biggest secrets of all, they're all hidden in the dark.